What's good, y'all? This is Colin with BC, so you could probably guess who I am. We're gonna nerd out a little bit in this video, as I like to do. Shit, this is gonna be the most unusual galaxies ever discovered. Space intrigues me. I like to learn new shit. If you haven't already done so, hit that subscribe button down below. Help me out a little bit. Uh, it's free, and it sure ain't gonna hurt you. Um, let's just get straight into this.
The number of stars in the universe is quite uncountable. Their number in the observable part of space may be upwards of a septillion, although the idea of actually arriving at an exact value is hardly feasible either now or indeed at any point in the future. Today's point in question is not stars but larger structures they make up. As we know, stellar systems, together with their rarefied gas and dark matter, form gravitationally bound structures called galaxies. According to different estimates, mankind is currently able to observe several 100 billion of them in different stages of their evolution. Let's talk about some of the most unusual ones.
I bet you there's more than a Googleplex, just in our observable universe. Probably in the observable universe.
Distances from the Milky Way to
or maybe
galaxies
just our
are by all accounts mind-boggling.
galaxy
As a
cluster
rule, it is
or whatever
anything
that's
from
called
millions
that
to
we're
billions of light-years. Due to the universe's cosmological expansion, the distance between the Earth and any remote object in the universe is constantly growing, which makes the light emanating from this object look redder than it actually is. This phenomenon is known as a redshift. It is of great help in gauging distances and velocities on the astronomical scale. Alternatively, some galaxies' spectrum is blue-shifted, which means that they're not on an escape trajectory from us, but on the contrary are moving to meet us. One of these unusual space objects is the galaxy M86 in the Virgo cluster. Roughly 52 million light-years away from the Sun, it is moving towards the Milky Way at a speed of around 244 kilometers per second, which makes it one of the fastest-moving blue-shifted galaxies. By moving at a high speed through the scattered gas the Virgo cluster is filled with, M86 is constantly shedding its own interstellar matter. As a result of this process, it leaves a trail of long lines of warm ionized hydrogen behind. M86 is connected with the almost destroyed spiral galaxy NGC 4438 with several of these filaments. These two galaxies are thought to have collided at some point in the distant past, which was the smaller one's undoing. Interestingly, M86 is known to have destroyed its other neighbors in the past as well. Several stellar streams have been detected in its halo that are likely to be the remains of smaller galaxies absorbed earlier. An impressive number of globular clusters in its structure is another outstanding feature of M86. Observations show that their number is upwards of 3,800, which is around 25 times as many as the Milky Way. There is a theory that claims these clusters to be the remains of dwarf galaxies that M86 would have absorbed in the past. If it really is the case, then it would have destroyed tens or even hundreds of other galaxies. Having said that, M86 looks anything but unique. The galaxy ESO 137-001, which we'll be looking at next, has a similar shape. But unlike M86, it appears more outlandishly original. Located 227 million light-years away from the Sun, it is as heavy as 5 to 14 billion solar masses. As for its stars, most of them are young and bright blue giants. ESO 137-001, in its turn, is part of Abell 3627, a large galaxy cluster. Moving to its center at an incredible speed of almost 2,000 kilometers per second, the galaxy collides with interstellar gas pressure inside the cluster. As a result, its own gas is blown out, leaving behind tails that stretch for up to 260,000 light-years. Incidentally, the mass of interstellar gas in those areas is 2 to 4 times that of the gas inside the galaxy. It is hardly surprising that starbursts are a common thing here. That is, stars don't stop forming in these enormous streams made up mostly of hydrogen. When
those
seen from the
tails
side,
stretch for so
ESO
damn
137-001 appears like
far.
a giant
What the
jellyfish
hell?
floating through endless expanses of space. Unfortunately, as the galaxy is continuously stripped of its
200
interstellar
and
gas,
some
its life
light
expectancy
years.
diminishes too. With not much material left, no new stars can form here, which greatly affects the structure of the spiral arms and central bulge of the galaxy. On the bright side, scientists have a chance of finding out more about dark matter and its interaction with other space objects by observing the behavior of the gas streams left in the galaxy's wake. Speaking about the formation of new stars, there is a galaxy with a name that speaks for itself: Baby Boom. Around 4,000 stars are born here every year, which is about 400 times more than in the Milky Way. Straightforward calculations show that on average, a new star lights up in this area of space every 2 hours. The Baby Boom galaxy lies around 12.2 billion light-years away from the Earth. This means that what we see when observing it is what was happening just 1.5 billion years after the hypothetical Big Bang. It was a time when the universe was still in the process of forming its structure. What is taking place in the galaxy now is drastically different from what we expect to observe there in theory, based on what we know about star formation. The reasons why stars are produced here at such an astounding rate are not known yet, but it is beyond any doubt that Baby Boom is able to provide us with a lot of information about the early stages of our universe's evolution. One of the few galaxies one can observe through an amateur telescope is the so-called Sombrero Galaxy, official designation M104. It lies 30 million light-years away from the Sun, and its diameter is roughly 4 times smaller than that of the Milky Way. The Sombrero Galaxy's outstanding feature is a massive ring of dust and cold hydrogen enveloping it. Observations show that it is here that most young stars are born. In addition to the peculiar ring, the Sombrero Galaxy is also remarkable for its elaborate inner makeup. Observations with the Spitzer Space Telescope show that most stars in this galaxy form a structure typical of elliptical galaxies. The stars here are mostly rather old yellow and red dwarfs. The other stars here, on the other hand, form spiral structures concealed within an elliptical cloud. It is thought that this phenomenon is a result of two galaxies' collision, with their stars subsequently and almost inevitably mingling together. It is incredible that the galactic structures survived a merge of that scale with minimal damage, are none the worse for this tremendous collision, and can still be observed.
That's a cool-ass animation right there.
Another peculiar feature in the Sombrero Galaxy is exceptionally powerful X-ray radiation emanating from the center. It is assumed that the accretion disk of a supermassive black hole may be its source. The mass of the hole is estimated to be over 1 billion solar masses, which makes this enormous object one of the most massive black holes known to science today. There are also several sources of tremendously high frequency or terahertz radiation detected within the galaxy, although today their nature is still a mystery. Our galactic parade today is concluded with yet another object boasting an elaborate inner structure, the eerie M64 Galaxy, rather aptly dubbed the Black Eye Galaxy. The nickname comes from a dark band of cosmic dust that partly conceals the galaxy's center from the observer on the Earth. Due to this line of cosmic dust, as well as the exceptionally bright active nucleus, it is impossible to estimate the Black Eye's number of stars even roughly. What we do know is that it is comparatively small and not so remote. Its radius measures 25,000 light-years, and it lies approximately 17 million light-years away from the Milky Way.
because there's probably life in each one of these galaxies that
is
they're
made up
listing
of two
off
well-defined parts.
But we'll just never connect
the
with
inner
each
disk
other.
with a bulge rotate in the direction opposite to that of the outer ring. The most likely explanation for such a bizarre makeup is that the galaxy formed after two smaller ones collided and merged in the distant past. Admittedly, it would take a combination of a number of mutually independent factors for such a fascinating and well-defined structure to form. For example, the progenitor galaxies would have moved at specific velocities and come together at a certain angle. The odds of a success would have been minuscule. The universe shows a rich diversity of hundreds of billions of galaxies consisting of
Yeah, it
downright
does.
countless stars of all makes and sizes, from tiny dwarfs to supergiants. Among these, there are countless amazing and unique worlds. Altogether, they constitute our wonderful and mysterious universe. If you feel like learning more about it, subscribe to our channel if you still haven't done so, and look out for our new and hopefully awesome videos. Let's keep in touch.
Alright. Yeah, there's gotta be life out there. I heard that there's more planets than there are stars in every galaxy. So, there's another Earth-like planet somewhere. Anyways, I like those kinds of videos. They amaze me because how can something natural have a structure like that? But anyways, I'll stop saying that too. If you haven't already done so, please hit that subscribe button. You'll be helping out someone in need. And it won't hurt you. And it's free. Like this video as you already should have. And then comment down below. What galaxy have you heard of that's amazing? I'd like to look up some that were not in this video. I've seen some before that were not in this video. And yeah. Let me know. Till next time, y'all. Take it easy.